Now let's take a look at axioms and postulates. An axiom is something which is accepted as true and it does not need to be proven. A postulate is another word for axiom. So if I told you 2 plus 2 equals 4, do you accept that as true? Yes, I don't really need to do a proof. So that's a postulate or an axiom. There are 3 postulates that I take straight from your notes in the book. The first postulate says through any blank points there is exactly one line. Remember, when I drew 1 point, I could do lots of lines. When we went back to our other notes at the beginning about lines, we said 2 points make 1 line. So we had to draw a second point to get that in. So through any 2 points, there's exactly one line. That means that any 2 points, since they determine a line, they have to share a line. They are collinear. All right? Then it says through any blank points, there's exactly one plane. Oh, we talked about that. When we went to the plane notes here, just before this, we started with the 2 points, and we said that's not enough to do a plane. We tried adding a point there. That wasn't enough to do a plane because these were collinear. We added a third point that was over here, and that is enough to do a plane. If you can make a triangle, you made a plane, all right? So we're going to say for any 3 non-collinear points, if I can fit it in here, there's exactly one plane. What that means is any 3 points will lie in a plane, so no matter which 3 points you pick, they are always coplanar, which means they lie in the same plane. Now, this is again strictly from your book. If 2 points lie in a blank, then the blank containing those points lies in the blank. So let's go take a look at our planes again. When we were talking about, actually I'm going to do lines. So if 2 points lie in a plane, so let's say I'm actually going to do it right here. 2 points lie in a plane. All right, so I'm going to put plane right here. Then the blank containing those points is also in the plane. Well, what we know when we have 2 points is we can always make pretend that's a line, you can always make a line. Is this line, even though it goes forever and pretend it's straight, is it ever going to come out of the paper? No. So the line is in the plane. So this says if 2 points lie in a plane, then the line containing the points lies in the plane. Okay. Let me go over the next example. 2 flat walls meet in the corner of a classroom. Which postulate best describes this situation? So, first of all, if I had 2 flat walls, that's kind of like having this sheet of paper and this sheet of paper. Where they meet, all the points that are on both pieces, both the side that's flat and the side that's like this, make this shape right here. And that shape is a line. Okay? So let's read the postulates and decide which one would work. Let's see. Through any 3 non-collinear points, there is exactly one plane. Well, I'm not really having the 2 walls meet in 3 non-collinear points. They're meeting like this. If 2 points lie in a plane, then the line containing them lies on the plane. No? If 2 lines intersect, then they intersect in exactly one point. Well, I really have planes intersecting, more than lines. If 2 planes intersect, then they intersect in exactly one line. So our answer is D.